not even 30 problems, and it's just solving equations, so like it's not bad, I don't think. Have we solved, I put the wrong thing on the board, they're exponential equations, have we solved them before? Probably, so hopefully this will just be like a refresher. So you've got to make sure that you have like the same basis, and then if you do, you can basically just set the exponents each other and solve. Is that okay? Yeah. So for the first one, we have the same basis. So some of these are kind of brief, but it's 2x minus 9 equals 7. And then we're just solving that equation. So what would we do to get x by itself? Add 9, divide by 2. So x is 8, and that's it. We okay? Excellent. So that's basically all we're doing. On the next one, it's the same thing. So is it okay if we skip that one? Yeah, you just say 4w minus 1 equals 5 minus 2w. And then solve. Is it okay if we don't do that? Okay, so for number 3, this is just a little bit different because we've got two things going on. So I need you to think back to exponent rules. If you have terms with like bases, what do you do with the exponents? You add them, right? So we would have that's c minus 1 plus 3c plus 2 equals 7c plus 16. So then we would combine like terms on the left side. So 1c and 3c is going to give us 4c, and a negative 1 and a positive 2 would be plus 1 equals 7c plus 16. What should we do from there?
Subtract 4c.
That's what I would do. You could also minus 7c, whichever one you want is fine. I just don't like negatives, so that's why I move the 4c. And then we'll move the 16 as well. So I'm doing this all at the same time. I don't know if you're probably fine to do that. So minus 15 equals 3c, and then we'll divide by 3, so negative 5 is c. Are we okay with all that? Yeah. Okay. 4 is the same thing, so is it okay if we skip that one as well? Yeah. All right.
That one, will we have to x factor?
Yes, we do. So actually, let's do that one. So we'll have k squared plus k, and then because these are multiplied, we'll add that. So plus 2k minus 9 equals 4k plus 11. So anytime we've got a squared, we probably need to try to factor. So we'll get everything on the same side first, and then try to x factor from there. So this is 3k, and then we'll subtract 4k, so we'll have k squared minus 1k, and then it'll be minus 20. So what will this factor into? Minus 5, k plus 4. So then when we solve, we'll have k equals 5 and k equals negative 4. So you can have more than one answer, and that's fine. Are we okay with that? Cool. So the next section is where they get just a little bit trickier, so they don't have the same basis. So we need to try to rewrite them so that they do have the same basis.
Do you have any topics in your right now?
I have one.
Okay, thanks.
Okay. So we're looking at this one. Any ideas how we could rewrite anything so that we have the same base? Right? So 81 is 9 squared, so we could just say that would be 9 squared over here instead. So then we have 9 to this stuff and 9 to the second. So I'm just going to say 4y minus 26. I didn't put a y. 4y minus 26 equals 2. Kind of skipping that step there, but I hope that's okay. So then we would add 26 divided by 4. So y is 7 there, and that's it. That okay? Awesome. So looking at the next one, we have 1 over 64, and then 4 to the a squared minus 4. So could we rewrite 1 over 64 with a base of 4?
4 to the negative 5.
To the third. Yeah. So we know that it's negative because it's like a fraction. So just keep that in mind. I am going to rewrite that out. So 4 to the negative 3. And then 4a squared minus 4. So at this point we could say negative 3 equals a squared minus 4. I would, because it's just the squared term, we don't have to factor. Does that make sense? Okay, so we'll add the 4 over, so we'll have 1 equals a squared. So what is a? Plus or minus 1. Yeah, don't forget those. When you take the square root, you get positive and negative. So are we okay with all that? Great. So looking at number 7, we've got a base of 2, and then we have a base of 32. So could we rewrite 32 as 2 to some power? Yeah, to the 5th, right? So because there's other stuff happening here, it's a little bit different. So we'll have 2 to the 5th times n plus 3. That's the only difference. So not too bad there. So I would minus m over, subtract 15 over. So we'll have 4m equals negative 24. So then negative 6 would be our answer. Are we still okay? Alright. So then looking at the next one, everything's got a base of 12, kind of. The only one we need to change is this one. So what do we need to do? Yeah, so just like negative 1 there. So we would have 12 to the negative 4x plus 3. And then because we're multiplying here, we'll add that x squared in the next step. Alright, so we're going to have negative 4x minus 3 plus x squared equals 2x plus 13. Are we okay getting to that step? So just remember, if they're multiplying, does it look like multiplication? That's what that should be. We'll add the exponent, so that's where that came from. Yeah. So what do we probably need to do here? Get everything on one side and factor, right? So because we've got an x squared and an x term, that's how we know you can't just like try to square root like we did on number 6. So we'll have x squared minus 6x minus 16, right? Yep. So what would that factor into? So minus 8 plus 2. So then x equals a positive 8 and negative 2. And that would be our final answer there. We're still doing okay? This isn't like groundbreaking or anything, is it? Good. Fantastic. That's what I like to hear. So we don't have to do all of these. We can do as many or as few as y'all would like. What do you want to do? Because like if we're good, then we don't need to waste the time on it. So let's pick like 2 more to do, and then we'll be done. Is that okay? Absolutely. What else do we want to do? 15? Cool. And if we want to do more after that, then we definitely can. So we'll start with 12. So any thoughts what our base maybe should be, just looking at what we've got going on? I want it to be 4. That just seems like that might be easier. Since they're both fractions, we know it's going to be negative whatever. So for the first one, it would be like negative 1, right? So we can go ahead and write that. It would be 4 to the negative 2x squared minus 6. And then for the other one, 4 to what power would give us 64? Yeah, negative 3 for that 1 over 64. So we'll say 4 to the negative 3 to x squared minus 5. Are we good with all that? Yeah. So we just have to remember to like distribute there. I don't think it's too bad. So what do we want to do from here? Did I multiply wrong? I multiplied wrong. This is 6, not 12. Goodness. I don't know what I was thinking. I guess maybe I looked at the 4. I don't know. Anywho, so we've got negative 2x squared plus 6 equals negative 6x squared plus 15. What do we want to do from there?
Add 6x.
Okay. So we'll add that over and we'll have 4x squared and then subtract 6 at the same time. Now what? So x squared is 9 over 4. And our last step? Square root. So anytime we take a square root, you get a plus and minus. And the square root of 9 over 4, you can take the square root of each individually, right? So that would be 3 over 2. And that's it there. We okay on that? Yeah. All right. So we'll look at 15. There is a bit more going on this time. We've got 1 over 16, 64, and then 1 over 32. So typically I try to just take whatever the smallest number is and make that my base. But 16 to any power is not going to give us 32 or 64. Do you agree?
Yeah.
So what should we try instead maybe? 4. So you could do 4. What else could you maybe do? 2. Okay, so 4 squared would give us 16. Will 4 to any power give us 32? That one won't work. So let's try 2. So 2 to what power would give us 16? To the 4th, so that will work there. 2 to the 6th would give us 64, and then 2 to the 5th would give you 32. If you 2 to the negative 4, x plus 7. And then we said that 64 was 2 to the 6th. And then 2 to the 5th. Oh, negative 5 because it was a fraction. And yeah, that should be good. All right, so on the left-hand side, what are we going to do with those exponents? Add. So distribute, then add. So negative 4x minus 28 plus 6x plus 30 equals negative 20. Then from there, I would combine like terms and move stuff over. So negative 4x and 6x is going to give us 2x. Negative 28 and 30 is 2. So I'll just subtract that and get negative 22. And what's our last step? Divide by 2. So x equals negative 11. Do we have questions on anything? Do we want to do any more? 13? All right. Yeah, this is a good one. So it would be awesome if we could do like 36 to some power and get 216, right? So what is 36 squared? Somebody check that real quick. Yep, so that's not going to work, right? So what can we try instead? 6, so like 6 squared would give us the 36. 6 to what power might give us 216? I would try 3, right? Because we know it's not squared. It is 3? Great, so let's do 6 as our base. So we'll have 6 squared times 2r. And then for the 1 over 36, what does that need to be? Negative 2. And then we said the 216 was 6 cubed. Are we okay with all that?
Yep.
All right, so 2 times 2r, that's going to be 4r. Minus 2 equals 3. So add 2, divide by 4. And that's it.
Are all our problems going to be able to find a root for this? Like all our numbers that we're doing? Because then we find
Will there be an
like,
answer?
I guess, like,
Yes.
there's not going to be one that we can't do it.
Right. You mean like as far as like rewriting the basis?
Yeah.
Yeah. They'll all be, yes, things that you can find. Do we want to do any more? So are we pretty good with those? Those are kind of the easier ones. All right, so if we're good on that, we'll move on to the next section. So these are just a little bit more involved because it's not like something to some power equals something to some power. So instead, there's a bunch of different ways that you can solve these. I think especially if it's something like this, it's easy to rewrite it with a logarithm because then it would be like log base 3 of 80 equals x and you're done, right? You just type that answer in, or type that in and that would be your answer. So that's what I did. You can take the log of each side so that you can pull the x to the front and then divide off what you don't need. But again, I think it's easier to do like around the world. So is that okay with y'all?
Yes.
Did you understand what I said when I said that at all? No? Cool. So I'll show you. So I think I talked, this was B-Day people when we did it around, did we do around the world? We didn't talk about that. So I think that's what Duncan used to teach people. So like when they got here, that's what we said. But obviously that's not happening anymore. So basically around the world just means the base is here and this goes on the inside and then this is like the other side. So it's log base 3 of 80 equals x is how you would like write that or say that or whatever. But you should already know how to switch from exponential to logs because we did that last week. So as I was saying, it's log base 3 of 80 equals x. And we can type this straight into Desmos, like in the graphing calculator. I don't know how to type this in the scientific one, like with a different base. So I just use the graphing calculator for those. It does it just fine. It'll get you the answer you need.
You know we did the fractions as a base of the base?
Like
I tried to do a fraction on one of the, like instead of the 3, like I would have put like 1/3 or something, and it's something you couldn't simplify as a decimal.
yeah.
So like, I don't know how you do it.
I know that I ran into that and I figured it out. I can't remember how I did it now.
Completely accurate.
So what? I remember I was sitting on my couch and I was like, how this doesn't work? Why does this not work? And I played with it and I figured it out, and that was over a week ago, so I don't remember now. Oh man, that's gonna drive me insane. I think,
I tried to put parentheses around it,
and that didn't work either. We'll have to play with it because I know that there's a way that you can do it. It might be that you just have to do change of base for that. So do we recall the change of base formula? So that's like, I'll use it with this one. So you would do like a log of 80 over log of 3. Whatever the base is, 3, always goes in the bottom, like the basement. That's how I keep it straight. You basically just split it. So if we didn't have a calculator that could do a different base for us, this is what you would have to use anyways. So maybe if you do run into a situation like that where you have a fraction or something, this might be a better route than typing it like this. But like I said earlier, the graphing Desmos will take this. You can type it straight in and get your answer. The scientific one, you would have to split it up and do change of base because I haven't figured out how to do a different base in there. I didn't know if y'all had figured that out at this point. So, again, I don't care how you get there. We just need to get an answer. And we're going to round 3 decimal places. So do whatever you want. Let me know what you get. So, yeah, you can either do the graphing one or the scientific one. I kind of think the graphing one's easier just because you can just type it straight in, but whatever is fun. Is it 989 or?
It goes on for a long session.
No, I had 3.987. I don't know if that matters, but.
It's 3.98869.
Is that when you type it in, so you did it in scientific with change of base?
Yeah.
That's what it is. Okay, so that's fine, but good to know. So,
It's not completely accurate. It's still good.
I don't know. That's weird because like change of base is like,
Shouldn't that be like exponential?
yeah, that's interesting. I don't know. I mean, it's very, very small that it's off, but still, I don't like that. So, oof. your homework makes you like type in your answers. So I'll just go change it. I gotta figure out how to make it not count off if you're off here.
You could just put like a range of answers or something.
Oh girl, it was a lot just to type in what I had to already. I'll figure it out. It'll be okay. But anywho, are we okay getting this answer? Or getting the 3.987 if you did it with change of base?
Yeah.
Yeah. Okay, cool. So you can do that for this one as well. We'll go ahead and do it just to like refresh our memories. If you have an e as your base though, we don't do like log base e. What do we put instead? Natural log. So we could say natural log of 140 equals x. And so then just do natural log of 140, and we'll round 3 places again. I want y'all to tell me what you get, because I'm like afraid my stuff's not the same. Awesome. That's what I got as well, which that one should be the same. Are we okay with all that? Great. So looking at the next one. We have more stuff happening in the exponent, which is fine. We'll still set it up the same way. So we'll do log base 5 of 18. Log base 5 of 18 equals x plus 1 this time. So we just need to figure out what log base 5 of 18 is and then subtract 1, and that would be your answer. So, I mean, I can tell you what I got, but it's going to be different. That sucks. So when I did change of base, I got 1.796. Yeah. Or maybe I did that with only graphing calculator. I don't know. Whatever. That's what I got. And then we minus 1, so it's just 0.796 for x there.
I got the same thing with doing,
Did you on that one?
Yeah.
That's so weird that that one's the same, but that one wasn't. Very strange. Anyways,
Can you do it down a little bit?
yeah, I'm sorry.
It's okay.
I'm the worst about that. And the paper will be like this, because like, I don't know, this thing is not straight. So like on my desk right now, or on this thing, my paper is turned at an angle like this, so I can't have it straight because then it's crooked for y'all. Anyways, we can do as many or as few as y'all want to here. So what I did for number 4, we can rewrite that as like 3 to the negative whatever. So, and then we don't have to worry about like odd things happening with trying to do like a 1/3 is our base there. So I think that's helpful. So we'll do that one. So we can make this 3 to the negative 2x minus 5 equals 120. And then from there we'll do like around the world to rewrite it. So we'll say log base 3 of 120 equals negative 2x plus 5. So one thing that I will say, because we're doing more stuff now, and especially later, I think it's helpful to try to leave this as long as you can so that like it's the most accurate answer we can get. Do you kind of understand what I'm saying? So like in my calculator, I would type log base 3 of 120 minus 5 all divided by negative 2 instead of doing it like a step at a time. It shouldn't change it that much, but just the most accurate that we can keep it, the better, or the more accurate we can keep it, the better. So yeah, do that real quick. Do you know how like, you can pull your answer on like a real calculator? Do you know that function, like second answer or whatever? Well, it's on there, and like I use it all the time. You can use it in the scientific Desmos, but you can't in the graphing, so that's just something to keep in mind. Whichever one you choose to use, it doesn't really matter. So anyways, for x, I got negative 0.321. Yeah. Are we okay with all that? Yeah. All right. So for number 5, this one's different because we've got like e to the 3x plus 25. So what do you think we should do first? yeah, so we want to make sure that we have that like exponential term by itself first. So we'll subtract 25, have e to the 3x equals 83. And then we can solve it like we have been for everything. So we'll say natural log of 83 equals 3x, then divide by 3. So I got 1.473.
Yeah.
Alrighty, looking at number 6. What do we think we need to do first?
6 divided by -2.
Yeah, that's what I would do. So we'll take care of that first. We'll divide by -2. So I'll have 8 to the 4 minus x equals 25. And then we can rewrite it with a log. So log base 8 of 25 equals 4 minus x. So then we'll subtract 4 divided by -1. And I got 2.452. Are we okay with all those? Yeah. Okay, so looking at 7 and 8, they're kind of more of the same. Do y'all want to do either of those, or are we okay to skip them? Okay to skip? Yeah? Okay. All right, so I do want to do the next ones because they're different. So we've got 2 to the x plus 5 equals 3 to the x minus 2. This is a problem for many reasons. We don't have the same basis, right? So we can't just say our exponents are equal and move on from there. And it's not just like 2 to the whatever equals 3, so we can't rewrite it with a log like we have been either. So at this point, we are going to take the log of both sides, which is what I was saying we could do with the ones before. And then that will allow us to pull the exponents to the front. And then we can like distribute what we need to, get all the x terms together, divide off the stuff we don't want. It sounds like a lot, so we're just going to do it. Is that okay? Okay, so this is one that I think is super important, again, to try to keep the logs in there as long as possible. And like at the end, our last step is going to be a bunch of log stuff over a bunch of log stuff, and that's what we'll type straight in the calculator. So don't type anything in until like our last step. So like I said before, first step is always take the log of both sides. So I'll write that out on this one. We'll have log of 2 to the x plus 5 equals log of 3 to the x minus 2. And you can use regular like log base 10, or you can use natural log. It doesn't matter, either way is fine, you'll get the same answers. I think I typically use natural log just because it's shorter to write, which is like a bad reason to do something, but that's what I do. And like I said, it doesn't matter, you can use either one because all the properties are the same and you'll still get the same values. So you can use log or natural log, either way is fine. But since we took the log of each side, we can pull that exponent to the front. So that would be like x plus 5 all times log of 2. And then x minus 2 all times log of 3. So then at this point, I would distribute the log here and here. So we'll have x times log of 2 plus 5 times log of 2 equals x times log of 3 minus 2 times log of 3. Everybody still with me? I'm going to zoom in a little bit because I see some squinty eyes. Is that a little bit better? So what are our thoughts from here?
Can you just explain
So are we good with just like taking the log of both sides?
Yeah.
Like that's the thing that you can do because we did it on both sides, so it's still balanced. Then we have that rule that says like your exponent can be pulled to the front in logs. That's just a property of logs that works. Are we good with that? So then we just distributed the log. It's kind of backwards from how we're used to distributing, but we just said x times log of 2 and then 5 times log of 2. And then same thing on the other side. Is that okay? Everybody else all right? Any other questions right now? Okay, so we got to figure out what to do from here. Typically, if we're like solving an equation that has x's on both sides, what did we do? Get them on the same side. So let's do that, okay? So we'll get these on the same side, and then we'll move this guy over here as well, so that we have like the non-x stuff on one side also. So we'll have x of, or x times log of 2 minus x times log of 3. And then we had negative 2 log of 3 minus 5 log of 2. Are we okay with that? Okay. So now looking at the left-hand side, do y'all remember when we were doing inverses and we had like xy terms? So it's maybe like xy plus 2xy, and we had to like pull out the x and then divide the stuff we don't want?
Yeah.
That's what we'll do here too. So we're going to factor out an x. That'll leave us with log 2 minus log 3, and we'll divide that off.
We're gonna like pull out the x and then do log 2 over log 3.
Nope. That's going to make it way more complicated later. So we're just going to leave it right now. So we're pulling out that x. That's going to leave us with log of 2 minus log of 3. Because remember, we're going to have to go type all this stuff in the calculator. So the simpler we can kind of keep it, the better, I think. So we'll have negative 2 log of 3 minus 5 log of 2. And then, like I was saying, we'll go ahead and divide this stuff off. So I'm going to write that in another step before I actually do anything. Don't feel like you have to do this when you're working on your own, but I do want us to be able to like see this a little bit better. So in your calculator, you'll type negative 2 times log of 3 minus 5 times log of 2 all over log of 2 minus log of 3. So I guess if you wanted to, you could condense that before typing it in, but I didn't. If you wanted to, you could like try to condense that a little bit if you wanted before typing it in, but I think that would just further complicate things to me. Because when we start doing that, sometimes we start making mistakes, and it's not that you didn't know how to get here. It was just that we did stuff afterwards, so. Are we still okay? Maybe I hope. So I ended up with 13.967. Yeah. Do you have any questions right now? So we're okay? All right, so 10, 11, and 12 are like all the same thing. We can do all of them. We can just do one more, two more, whatever you guys want to do.
Can we try one on our own?
Do y'all want to try one on your own now, or do you want to do one more together first?
Together. More together.
We'll do one more together, and then we'll try one on our own if we feel more ready. Okay, I'm going to use natural log this time, just because it's smaller and this to right. We'll get all the same answers. If you want to continue to use a regular log base 10, that's totally fine. I'm just going to switch because I'm a little bit lazy there. So we'll take, first off, we need to try to see if we could rewrite it with like same bases. Could we do that here? No. And it's not just like 8 to the something equals a number, so we can't do like around the world either. So that's how we know we have to do it this way. Does that make sense? So we'll do log of each side or natural log of each side, whichever one you want to do is fine. So we'll do natural log of 8 to the 2x minus 1 equals natural log of 5 to the x plus 3. So then once we've taken the natural log or log of each side, what can we do with our exponents? Pull them to the front. So we'll have 2x minus 1 times natural log of 8 and x plus 3 times natural log of 5 . So what's our next step? We'll have 2x times natural log of 8 minus 1 times natural log of 8, so just minus natural log of 8. And then we'll have x natural log of 5 plus 3 natural log of 5. We still okay? Then what do we try from here? Yeah, so we'll get our x terms together. So I'm going to subtract this one over and then add that one over. If that makes sense, I hope. So we'll have 2x natural log of 8 minus x natural log of 5 equals 3 natural log of 5 plus natural log of 8. So now that we have our x's on the same side, what do we do from there? Yeah, so we want to factor that x out. So there may be times when, like, if you're thinking in terms of GCF, there's more you could pull out, but it's not necessarily helpful because we want x, right? So that's all you want. Don't make it harder. Just pull out what you need and leave everything else in there. 2 natural log of 8 minus natural log of 5. And so at this point we just want the x, so we'll divide off all the stuff that we don't want. I keep forgetting that too. So again, you don't feel like you have to write this last step here. I'm just doing that so that you can see what it is exactly that we're typing in the calculator. So yeah. We should have 3 natural log of 5 plus natural log of 8 all over 2 times natural log of 8 minus natural log of 5. And I end up with 2.710. Do we feel a little bit better after doing that one? Are we good enough to try it on our own, or do we want to do another one together? Yeah, try it on our own. Is that okay? Do you want to do 11 or 12? 11? Cool. So try 11 on your own. I'll give you a few minutes and then we can talk about it for sure. Or is supposed to be, or do you need to walk through it? Okay, so if we didn't get the answer, then we can walk through. But I got negative 1.542. Do we need to see anything worked out there? Do we have any questions? Are we okay? Do we need to do 12? So if you're good, I'm good. You've got plenty of practice with like the homework and stuff, so that's all that. If you did 12, anybody do 12 and want to check their answer? Negative 0.353. So if we're good, you can go ahead and move on to homework. It's mostly all the same. So it's a little bit of like mixed stuff. So whenever you're working through them, the first 2 pages are going to be like the first 2 pages of the notes. So you're just setting the bases are the same, or you're trying to rewrite with the same base. And then the second page is like around the world, and then the last one is like what we just did. But there's only 4 that are like that, so it shouldn't be too bad. And you'll enter all your answers in Canvas, where you like type it in, because it's all numbers, so it shouldn't be too bad there. I rounded 3 decimal places on everything, so if you need to do that, we'll go 3. We all right? Okay, so y'all can work with people. Just make sure you're socially distanced and stuff.